Welcome to Network Topologies. In this video we will going to talk about networking topologies like the bus topology, ring topology, star, mesh, partial mesh, and hybrid topologies. To describe better the networking topologies, we will going to use logical diagrams. Logical diagrams are very similar to maps. Let's say that you would like to get from London to Berlin with a car, and to be sure that you're choosing every time the correct path to reach your destination, you will have to consult a map. In networking world, that translates like, how do I get from host A to host B? So if you want to know how to get from host A to host B, you will have to use a logical diagram which will show you the path that the traffic is taking. So for example, you can pass some switches, some routers, some access point on your way to the destination. First, we were going to talk about the bus topology, in which every PC or host is connected to the bus cable, like you see in our logical diagram. Now, a signal will travel from the source in both directions, like this. Until it finds the intended destination. If the machine address does not match the intended address of the data, the machine will ignore the data. Alternatively, if the data matches the PC, the data is accepted. Because the bus topology consists of only one wire, it is not expensive to implement when it's compared to other technologies. But the drawback of this is the high cost of managing the network. Another one is the single cable, which is the single point of failure in our case. Let's take, for example, the Metro Ethernet technology provided by some ISPs to their customer, where they have a loop of a fiber optic cable like this. And in this loop, they have different customers, like for example, let's say this one is company A, over here we have company B, company C, for example. Everyone is connected to the same cable in our case, and for example, everyone can see everyone, everyone can talk to everyone. Let's say that, for example, company B will be able to see what company A is doing. Maybe it will be able also to intercept some kind of traffic. Moving further, in ring network topology, which is set up in a circular fashion, like we are seeing here in the picture. The data travels around the ring in one direction. Let's say that the data will be able to travel like this. And as it travels around the ring, each device on the ring acts as a repeater to keep the signal strong as it travels. Each device incorporates a receiver for the incoming signal and a transmitter to send the data to the next device in the ring. The network is dependent on the ability of the signal to travel around the ring. When a device sends the data, it must travel through each device on the ring until it reaches the intended destination. The main disadvantage of the ring topology is the fact that every node is a critical link. Remember last time when we talked about networking devices and we used the neighborhood picture to describe how different people can connect between each other, using, for example, a switch or a hub. And for that type, we use the star topology. The star topology, it's very common in the networking industry, and it looks very similar to what we have on the screen. Of course, it doesn't necessarily have to look like a star in real life, but all the nodes of the network must be connected to a central device. The star topology is considered the easiest topology to design and implement. An advantage of the star topology is the simplicity of adding additional nodes. However, the primary disadvantage of the star topology is the hub or the switch that represents a single point of failure. So, for example, if the switch is going to be down, then you will lose your connectivity throughout the network. Let's say that, for example, you're running out of ports on this switch, and you will have to connect additional computers to this network. You're going to use a straight through cable going to another switch. Regarding the straight to cable, if you don't know what it is, go back to the second video where we are talking about cables. So once your switch is connected, you can add additional computers to your LAN environment. And this type of technology is called an extended star. Regarding the mesh topology, the things are pretty simple. Every node, every PC, or every device is connected between each other fully. In case one link will be down, then the traffic can take another path, like for example this one. You have no problem of reachability until your bad cable is fixed. Let's say that you don't have the money to build a mesh topology. In this case, you might try to consider partial mesh topology, which looks like this. And usually in a partial mesh topology, when, for example, let's say that you'll have your headquarters over here, and these are all branches. As you can see, you will have only your headquarters as the main point for everyone. But in real life, it's more like a combination of two or more networking topologies. And that is defined as a hybrid topology. For the hybrid topology, we are having, let's say, for example, our headquarters in New York, and the rest will be branches: California, Berlin, Paris, London, and so on. Over here on the core, we have something like a partial mesh topology, but let's say that these links will go down. In that case, you have a ring topology, and you see how these types of topologies can be mixed. On the HQ quarters, you can see how we have extended star topology. And if you pay a close look to the extended star topology, you will notice that I have done a mistake. You should never do this in real life. The mistake here is the fact that I used two switches like this. This is the perfect example how to do a bad design for a network. Instead of using these two switches here, I could have used simply only one. This could have disappeared and the cables could have been connected like this. To avoid mistakes like this, Cisco has designed a 3-tier architecture to avoid simple mistakes like this. which are like pretty normal if you're a beginner in the networking design. The three-tier architecture is based on 3 layers. First is the access layer, then you have the distribution layer, and third you have the core layer. We will start with the access layer. At the access layer you have low-end switches like 2950s or 2960s, which don't necessarily need to have too many features like the intelligence to route IP packets, but they need to have the amount of ports for connecting the end user PCs or servers or printers. On the distribution layer, you need to consider both the amount of ports, which is not entirely critical, but the switch or the router that you put there needs to have the intelligence or the ability to route the packets from one network to the other. So let's say that over here we have 2 networks, network A, network B, which have different IP subnets. The router should, or the switch, or the layer 3 switch in our case, should be able to route the packets from host X to host Y, and the traffic should go like this through the router. Interconnecting the devices at the distribution layer, we will have the core layer, where the speed, redundancy, and the intelligence are required for the data to move as fast as possible. This is the most desirable design that you should have in your network. But in case you don't have enough money to buy this amount of devices, you can simply eliminate the distribution layer and connect directly to the core layer. This 2-layer architecture is called collapse core. In case you want to read more about the networking topologies like the bus, ring, star, mesh, partial mesh, and the hybrid topologies, I will put some link in the description, as well as for the 3-tier architecture and collapse core. Don't forget to subscribe, hit the like button, and talk to you guys in the next one.